So let's look and see about lumber compression. This is sort of goes along with the computation quiz. Finding values and doing some computations is essential for the designer. So that's what we're going to work on here. And so this is an example of the table. I know it's hard to read, but I'll give you a larger version when you do the quiz. But let's take a look and see how we might use these. First, let's figure out how to find design values. Now, these design values that we're talking about are the maximum stresses that a certain size of a species with a certain grade can handle without failure. So they're design limits. And that's really important for us to know. So how would I do one of those? If I had a 2x4 Doug fir, okay, select structural, I know that it's going to lie along this line. Those are the numbers, the ones that I just showed right there. Those are the numbers that go with select structural. So then I need to know what type of stress I'm thinking of. Let's say it's parallel to the grain. So I would follow parallel grain down until I meet that line. If it was construction grade, I'd highlight my construction grade, and horizontal shear, I'd follow it down until I got to that line. So that's how I use the chart to find the values. And remember, those are maximum stresses that are allowed in the design in that type of loading. Okay, so that's what we just showed about here. Let's take a look and see. Check that the lumber chosen is adequate for the design loads. So the first thing I have to do is I have to know what the design load, the design stress is. Okay, and the engineer will give that to me. So let's say I've got a design and it says that my compression parallel to the grain is 2,000. And my engineer says he's planning to use 2x4 Doug fir of construction grade. So I'd have to go look and find parallel to the grain. And I want to make sure that the number I see in the book is bigger than what the engineer gave me as what will be applied. So he said 2,000 will be applied. She said 2,000 will be supplied. And 1,650 is the limit, so it's too big. So I would have to reject it. Okay? If the engineer had told me it's 1,600 and they are using select structural, come across, 1955 is the limit, 1,600 is what's being applied, 1955 is bigger, so I can accept that. It's okay. All right, the last one is finding the load. Okay, and I have to do a few things. The first thing I have to do is find the stress limit like I just did, and then I have to compute the stress area. The stress area is looking on end like of a 2x4. So if I had two 2x4s nailed together, it would be a 1.5 plus a 1.5, a 3 by 3.5, 10.5 square inches. So if I multiply my stress limit, pounds per square inch, times how many square inches, I'll get how many pounds I can do. So let's do a quick example. Okay, so here's one that says it's a 2x4. Let me pull up my handy dandy calculator here. I've got one 2x4, so I know its area is 1.5 times 3.5. And let's say that I'm interested in tension. I'll do compression. Compression of select structural. Okay, so I read it. That's 1955 is my limit. Pull this up over here where we can see it. 1955 times 1.5 times 3.5. That can hold that 2x4. Select structural. Doug fir can handle 10,263.75 pounds in compression. That's a lot of weight. Okay, so those are the ways that you can use these tables to answer questions, make some computations, and answer questions about the design.